Hello everyone, welcome back to this online class. So, in this class, so far we are studying heterocyclic compounds. This is Unit 4 and Unit 4. So far we have studied pyrazole, imidazole and oxazole. In today's class we are going to study about thiazole. That's the next heterocyclic compounds. As you can see on the screen, thiazole is 5-membered unsaturated heterocyclic compound with the two heteroatoms, two different heteroatoms. One heteroatom is sulfur, the other heteroatom is nitrogen, and sulfur is numbered at position 1, and nitrogen is at position 3, and numbering starts from sulfur, not the nitrogen. This is because that is the IUPAC nomenclature rule. According to this rule, you have to number sulfur first, because sulfur comes in the periodic table. I mean, sulfur exists in the periodic table onto the extreme right, then compared to the nitrogen. That's why sulfur is at position 1, or sulfur is numbered as position 1, and nitrogen is numbered at position 3. So in the other structure here, you can see sulfur has got 4 free electrons, right? And nitrogen has got 2 free electrons. We will see why it is like that in the next slide. So, and these thiazole derivatives occur naturally. You can see them in thiamine. Thiamine is a vitamin B1, and you can also see them in bleomycin. Bleomycin is also a natural product. It's an antibiotic. You can get this antibiotic from fungus, streptomycin. So it occurs naturally, and the thiazole derivatives occur naturally. So one is in thiamine, the other one is in bleomycin. So apart from this, we can also prepare thiazole derivatives as medicines, which we are going to see them later in this class. Alright, let's go to the structure of thiazole. Let's study the structure of thiazole in detail. So thiazole has got 5 atoms. Out of 5 atoms, 3 atoms are carbon atoms. One is sulfur and one is nitrogen. Let's look at the orbital structure of each one of these. So it has got 3 carbon atoms. In the carbon atom, carbon has got atomic number 6. That means it has got 6 electrons. Out of 6 electrons, 2 electrons go into first principal level, so it will go into 1s2. So 4 electrons are remaining. The 4 electrons go into next principal level, that is 2, level number 2. In level number 2, you have uh, uh, subshells. In the subshells, you have S subshell and two P subshells. In two P subshells, you have two Px, Py, and Pz. Initially, the 4 electrons are going to be like 2 in 2s and 1 each in 2px and 2py. So after hybridization, that is in stable stage. So after, when it is in excited stage, it's going to be in excited stage when it is going to form the bonds. So in excited state, they get sp2 hybridized. In case of thiazole or other heterocyclic compounds, they get sp2 hybridized. So sp2 hybridized are 3 hybrid orbitals, right? 1s and 2p orbitals. So each one of these sp2 hybridized orbitals will get one electron. So one more electron remaining. So one more electron will go into unhybridized 2pz orbital. So four electrons got distributed. The one each electron will go into sp2 hybridized orbital of carbon. Now this sp2 hybridized orbital of carbon is going to, they are going to form sigma bond with the other atoms. Let's consider at position number 2, carbon at position number 2. So that is going to form sigma bond with one sigma bond with the sulfur, one sigma bond with the nitrogen, and one more sigma bond with the hydrogen. Hydrogen is not shown here. So three sp2 hybrid orbitals are utilized here, right? See, the remaining is one unhybridized p orbital. It has also got one electron, and that way that is shown here. You can see here unhybridized p orbital with the one extra electron. So same thing is going to happen here with the at position 1, 2, 3, fourth position and fifth position. They are going to form sigma bond with the adjacent atoms, and one each electron from unhybridized p orbital will be remaining. So we have three unhybridized p orbitals with one electrons each. So next atom to be considered is nitrogen. Nitrogen has got 7 as atomic number, so that means it has got 7 electrons. Out of 7 electrons, 2 electrons will go into the first principal level, and you have 5 electrons. 5 electrons to be filled they are supposed to go into the next principal level. So comparing to carbon, it has got one more electron. Even this is going to form sp2 hybridization, means one extra electron will be remaining. Let's see where that one extra electron will go into. That one extra electron will go into sp2, one of the 3 sp2 hybrid orbitals. That is shown here. As you can see here, 2 extra electrons here, right? And there will be one electron in the unhybridized p orbitals. You got 3 electrons from 3 carbon atoms and 1 electron from nitrogen atom. Total 4 you got so far, free electrons. So next one is the sulfur. Sulfur is has got atomic number 16, means 16 electrons. As you can see here, the distribution 1s orbital. The first principal level, or the shell, is going to have 2 electrons, and for the next shell, that is shell number 2, is going to take 8 electrons. So they are going to be 2s, 2px, 2py, and 2pz. So they are going to take 2 each electron. So that second principal level is filled. For the third principal level, so you're going to have 6 electrons. So now this condition is one similar to the oxygen that we have seen in the last class. So in this case, out of the 6 electrons, 2 electrons are going to be in the unhybridized p orbital, right? So another 4 electrons will be distributed like in 3px 1 electron will go into that, and then 3py 1 electron will go into that, and 3pz. So you're going to have 2 electrons in that. Totally here it is like the first 3 p orbitals are going to have 1 electron each. The third one is going to have 2 electrons, and in the unhybridized p orbital, 2 electron is going to uh, go into that. So we are going to have total 4 electrons here, but 2 electrons from unhybridized p orbitals. So totally we are going to get like 3 from carbon, 1 from nitrogen, and 2 from sulfur from their unhybridized p orbitals. So these unhybridized p orbitals are going to form a cloud. So they're going to form a pi bondings. So because of this pi bondings, the cloud is going to form, and you're going to have that delocalized electrons, and these are already like in a ring form, and they are flat, so they have that conjugated pi electrons, delocalized electrons, and it will also fulfill that Huckel rule. It has got 6 electrons. That's why thiazole is an aromatic compound. So in this structure here, you can see on the S it says thiophene like. S means it will behave like thiophene. This particular atom here, sulfur will behave like thiophene, and the nitrogen over here, it is going to behave like a pyridine. So that's why it's called a pyridine like nitrogen. So that is about the structure. Next we will go for the synthesis. The first method of synthesis is from alpha halocarbonyl compound. You can see here chloroacetaldehyde is getting condensed with the thioformamide. This is the chloro, then acetaldehyde. These are, as you can see, the aldehyde group here. This is chloroacetaldehyde. It gets condensed. Condensed means removal of a water molecule there, as you can see here. So you need heating for this reaction. 1 molecule of hydrochloric acid is going to get removed. So chloroacetaldehyde is getting condensed with the thioformamide. Uh, as you can see here, instead of carbonyl group, the sulfur is replaced here. Name of this compound is thioformamide. So you're going to get thiazole, right? So this is the first method of synthesis. We'll go for the next one. The second one is Gabriel synthesis. This synthesis is similar to Paul-Knorr synthesis of thiophene. So here acyl amino compound, acyl amino compound, you have come across this acyl amino compound, right? So this acyl amino compound is going to react with the phosphorus pentasulfide, and here rearrangement is going to take place here. As you can see with the arrow marks, this double bond of thiazole is going to come from the hydrogen from here, hydrogen from this carbon, and one more uh, double bond is going to come from the hydrogen on the that is attached to the nitrogen here. It is coming to come from there, and the electron from double bond is going to shift on the oxygen, right? You are going to have the OH over there, and from there and that combining with this hydrogen will give you a molecule of water. You're going to get a dehydrated reaction here. With that, you're going to get the product 2,5 dimethyl thiazole. That is your product. This is Gabriel synthesis of thiazole. It is very similar to your Palmore synthesis. Next one is synthesis from thioamide. Synthesis from thioamide. So thiamide, they both are same. Thiamide is going to react with the chloroaxyrenes. This is chlorooxyranes. You have come across this product at the beginning in the heterocyclic compounds. This is a three-membered heterocyclic compound with the oxygen as a heteroatom. So this is one of the two chlorooxyrans. So there is substitution on two chlorooxyrans. So you have substitution at position number 2 with the methyl chloro group. So that is the substitution here. So combination of these two when they react, so you are going to get the substituted product here on the right hand side. So this is the third method of preparation of thiazole. Next we'll go for the properties. In the properties, physical property, thiazole is a colorless liquid with the boiling point 177 degrees centigrade. It has got pyridine like odor, and it is miscible or soluble in water. So with the chemical properties, it is a weak base. So because it is a weak base, it will react with the acid. So it is going to have that protonation reaction. That means you are going to get a hydrogen reacting with the nitrogen. Hydrogen reacting with the, let me show that here. With this nitrogen, hydrogen is going to get bonded, right? So and that is going to have that is going to have a quaternary amine over there. So it forms a stable crystalline salt with the strong acid. Being a base, it can do that, and it will also get quaternized. It will get just like just now I told. So it will get quaternized also. So next chemical property we are going to see about the chemical reactions. First one is electrophilic substitution reaction. So the electrophilic substitution reactions, it is a little resistant. It is not going to give you that free flowing all reactions like what we have studied in pyrrole, like sulfonation, nitration, halogenation. It is having little difficulty in giving the reactions, but the attack is going to take place at C5, that is substitution is going to take place at the fifth carbon. As you can see here, sulfonation under drastic condition, it is going to happen, and substitution will take place at position number 5, substitution in the presence of oleum. Oleum means a fuming sulfuric acid. There we used concentrated sulfuric acid. Here even more drastic condition is required. So thiazole in the presence of fuming sulfuric acid and mercury sulfate. Mercury sulfate is used here. Mercury is shown here. Mercury sulfate at 250 degrees centigrade, it is going to give you thiazole substitution, thiazole derivative at with the substitution at position number 5. It is thiazole 5. Sulfonic acid is the product you are going to get. So next is the reaction with the nucleophilic reagent. Even it is nucleophilic reagents are not going to attack easily on thiazole. Even this reaction is a little resistant. Here potassium amide is used. Right here, what in the presence of liquid ammonia, KNH2, it is going to split into K plus and NH2 minus. So NH2 minus is a nucleophilic agent here. Okay, this nucleophilic intermediary, it is going to attack at position number 2 here. So nucleophilic reaction is going to take place at position number 2. So this will attack on here, and this is the product you are going to get, 2 amino thiazole. So substitution is going to take place at position number 2. So next reaction is oxidation. So even this is resistant to oxidation or oxidizing reagents like nitric acid, but a little drastic condition is also used here. Um, it is going to react with the peroxyacetic acid. So it is going to react with peroxyacetic acid and going to give that oxidation reaction. Peroxyacetic acid, you can see the structure here. It is just like acetic acid. You have one more oxygen, one extra oxygen over here. So reacting with this, so you're going to take this as the starter product, 2,5-dimethyl-thiazole, reacting with peroxyacetic acid. It's going to give 2,5-dimethyl-thiazole and oxide. So oxidation is going to take place here um, at nitrogen, right? So nitrogen is going to have the oxygen over there. This is a quaternary ammonium salt. So the product is 2,5-dimethyl-thiazole and oxide. That is the oxidation product. So next is reduction. Even the reduction reaction is resistant. That means thiazole is resistant towards reducing agents, but here Rani nickel is used here um, by passing hydrogen gas over it in the presence of methanol. So Rani nickel is like porous, a special kind of nickel. It's very porous in nature. So here you are taking 4-phenyl thiazole, subjecting that to gaseous hydrogen in the presence of Rani nickel. Um, you are here you are taking methanol as liquid, the medium. So ring opening is going to take place here. In case of oxidation, ring opening did not take place, right, as you can see here, but in this case reduction, ring opening is going to take place. This is the product you are getting. You can compare this product with the initial chemical. See, you have C6H5, right? That is from here, and you have NH2 from this nitrogen from thiazole here, and you are going to get CS3 is from this carbon, C5 carbon, and you're going to get hydrogen over there. And this product is 1 amino ethyl, 1 amino ethyl benzene. That is the product you are going to get. That is the ring opened product. That is about the reduction. And next is the medicinal uses. As I have already told, so it is also available as a derivative in natural products. One is thiamine. Thiamine is a vitamin B1. Deficiency of thiamine, one will get the disease called beriberi, right? The other natural product that can contain thiazole is bleomycin. Bleomycin is a natural product obtained from fungus Streptomyces. Right. Apart from this, you can use thiazole to prepare the medicinal compounds which can give these pharmacological actions. Their actions are like anti-allergic. You can see thiazole ring in anti-allergic products. You can see thiazole in anti-hypertensive product. You can see thiazole in anti-inflammatory product. You can see thiazole in antibacterial products, even many of the antibiotics also, not just bleomycin, other antibiotics also, they are anti-tumor agents, right? The bleomycin is anti-tumor agents. You can also see them in sedative and hypnotic products. So here are the two examples. The first one is meloxicam. You can see the thiazole ring here, right? Meloxicam is NSAID, non-steroidal anti-inflammatory drug used for pain, right? Pain, fever, um, inflammation, redness, swelling. But here, meloxicam is particularly used for arthritis. It is not little used as anti-inflammatory because there are other less expensive or easy products are available as anti-inflammatory agents. But this is used in arthritis. Arthritis, as I told you before, it's inflammation in the joints. So next compound is the medicine is chlormethiazole. Chlormethiazole, it's a simple structure as you can see here. Um, a thiazole ring, okay, attached to the these substituents here, the side groups. The ring, the moiety is a very simple structure. So it is used as a sedative and hypnotics. Where are the sedatives and hypnotics are used? It is a sedative and hypnotic, so it can cause sedation, right, and hypnosis. But it is used in anxiolytic, or it is used as anxiolytic agents, like in anxiety. It's used in anxiety. So sedative hypnotics, they are also used as anti-convulsants. So it is also used in the treatment of alcoholism. The person who abuses the alcohol, frequently takes alcohol, do not have control, um, in abstaining from alcohol. In such people, it can be used to treat this alcoholism. So that is about thiazole. In this chapter, what are we studied? Um, we studied about its occurrence, right? We studied about the structure, we studied the synthesis, we studied the reactions of thiazole, then we studied the medicinal uses of thiazole. Alright, thank you very much, and let me know if you have any questions.